put from another mixing desk or maybe a DJ console. These sort of things will provide signals which are very hot, and you will probably need to put the pad in. So the volume in my mind has been produced with confidence. We've used good microphone technique. We've sent the signal to the mixing desk. We've applied the pad or not, and then we've applied an amount of gain to get the volume that we want. The next thing that we hit in terms of the mixing desk is the EQ section. Now the EQ section can add or remove gain. It depends on whether you are boosting frequencies, as I've done here, or you are turning frequencies down. If we are boosting frequencies, by the nature of boosting these frequencies, we are bringing more gain into the signal path. Sometimes, if you decide that you want to make your signal brighter in some way, and here I've chosen a frequency and I've increased the brightness of this signal, it will now be louder because this process has added electronic gain. Sometimes you might want to reduce slightly the fader to make a gain adjustment that backs off the additive process of adding EQ. So we've dealt in detail with EQ in other sections of the course, but I just wanted to remind you that the use of EQ is affecting the overall gain, the overall energy that's going to be heard from the PA system. So in terms of this signal path of voice to microphone to gain to EQ, the next place we're coming to is the actual fader itself, the channel fader. Now when you look at this, I can obviously turn things up, I can also turn them down, and this will be your primary way. Once you have set up the channel, this is your primary way of setting gain structure. So my microphone, which as you can hear is being turned up and down here, this is not the final place for gain. This output, in fact all of the outputs throughout the whole mixing desk, in this case are being mastered by the main faders, and the main fader that we're using for the PA system is this mono fader here. We only have, in this case, we have one speaker which is facing directly towards us, so I'm patched it into the main master mono fader, and this acts as an overall master for all of the channels that we're mixing today from this speaker. So we're at these balancing between these two faders. Back to the mixing desk. Remember, if we turn down the master fader, it doesn't matter what we do with the rest of the faders, nothing will be heard because we do not have the master fader at an appropriate position. Now I'm going to discuss with you what are appropriate positions for all of these faders, but for now we're still following the path of gain structure through the mixing console to the speaker. So I have my signal, it's being mastered by the mono. It then comes out of the mixing desk. We have a cable which is effectively going into the amplifier. The amplifier is here, and now we have yet another place in which we could set gain structure. On the front of this amplifier there is a gain knob. If you go to, this is a digital amplifier and it also has a set of digital controls. Your amplifiers may have just a single knob which you can turn all the way up to 0 dB. It would be normal to have your amplifiers turned to full up. It's not true that amplifiers make noise. Amplifiers don't make noise of themselves. They only amplify really the noise that's being sent to them. So it's generally not necessary to turn your amplifiers down. I like to see these things set to 0 dB. That's all the way up, and it really generally will calibrate the amplifier correctly for its power and the capability of your speaker system. So I've just put here for you a more of a traditional amplifier. This is an analog amplifier. It has no digital front end. There's no processing. So it's a very simple amplifier. And if we look in detail at the gain knob, you'll notice that when it's full up, the marker on the knob, and please forgive me, I can't see this because I'm using this thing backwards, but the marker on the knob is at 0 dB. So on most professional amplifiers, when they are turned full up, they are not attenuating, they are at this calibrated 0 dB position, which is generally a good place for you to start when you're setting up your PA system. So we've nearly completed the story of gain structure. We've been from the microphone, through the mixing desk, out of the mixing desk, into the amplifier, but we're not quite finished yet. We then go over the good quality copper that I was speaking to you earlier, that we want to be 2.5 millimeters minimum, and we eventually end at the speaker. But the speaker itself has a gain structure. And in an earlier lesson, we were looking at the fact that different speakers of different sizes bring better efficiencies to the party. And when they are more efficient, we get more sound out for the same amount of watts going in. So we could really regard the speaker itself as being part of this gain structure performance chain. So a question we're often asked is it possible to overdrive a speaker or damage an amplifier? Well, in general, if we overdrive things, if we go outside of the parameters, the electrical parameters and the limits that these devices can deal with, you're not going to damage the amplifier, but the amplifier will probably damage the speaker. Now, this is one reason why in the digital age, with digital amplifiers that have got processing built into them, the amplifier knows the type of speaker. In fact, when with this L-Acoustic speaker, we program it into the amplifier and we select it as a preset, and then the amplifier knows the limitations of the speaker and it will refuse to send to the speaker signals that would damage it. An important part of a PA system is cost of ownership over a period of time. And although these systems that have this kind of digital signal processing which gives protection, although they are slightly more expensive, over the long run you will damage far less equipment through misuse or accident. And so it's highly recommended that you use a system that has this kind of well-knowledgeable protection. This kind of facility where we protect the speaker within the digital signal processing, we use the acronym DSP, where we give this protection. This is implemented in what we would regard as high-level, high-end audio systems. And these are the systems that I really hope that you are considering for your next installation. However, you will see this kind of technology creep into the mid-range, the MI market, the music shop orientated bought product as time progresses. Now, if you do not have amplifiers that offer this kind of control and protection, it is likely that you might have some other kind of processing device, like a system crossover, which has limiters built into it. And this is also an acceptable way of giving protection to your speakers. However, it is not as encompassing as actually knowing the speaker within the DSP settings of the amplifier. So we've nearly finished our story of how gain gets to the listener. But the final thing that's adjusting gain structure, even once we've taken into account the efficiency of the speaker, is of course my distance from it. And the same rules that we applied to the microphone when we discussed every time we halve the distance, we double the sound pressure by 6 decibels, then the same thing is going on with the speaker. Every time we double our distance from it, we are effectively losing 6 decibels of sound pressure. And we've discussed this in the acoustics module earlier on. So in one final conclusion, I just want to repeat again the flow of signal all the way from my performance to the hearing, and just remind you again where gain structure can be controlled. Number one, it's in my mind to provide a certain amount of sound pressure. Number two, I decide how much sound pressure gets generated into the microphone by my proximity to the microphone itself. Number three, we enter into the front of the mixing desk and we have a line level signal, or otherwise known as a pad, which we can engage or not engage, which will turn down by 20 dB. The next point, we have the main channel gain knob, which allows us to trim the incoming signal on the microphone preamplifier to set up an appropriate level of signal for the rest of the electronics of the desk. Number four, we have the EQ section, which if we turn EQ up, we are adding overall gain. If we turn EQ down, we are removing some overall gain. Number five, we move to the channel fader, and here we get another chance to turn up level or turn down level. Number six, we have the master fader for the overall mixing console, which is controlling the overall level, not just of one channel, but of all channels. Number 7, we enter into the land of the amplifier and maybe your limiters or your crossovers, where we can set the gain structure that's on the front of the amplifier. And we're recommending 0 dB to start with. Number 7, we have the efficiency of the speaker itself. Is it a speaker which is highly efficient, giving us a lot of output for the electrical input, or is it more compromised in the amount of electrical energy that's going to actually need to provide good audio? And then finally, number 8, we have the distance of the listener from the speaker itself. And this is the path of gain structure from performer to hearer. Okay, so here comes the detail on how we would use these controls to set an appropriate amount of gain structure for an example microphone in this case. So here we go. We're going to start from scratch. So I'm going to assume that maybe my channel fader is down. I'm also going to turn down my masters. The only one that really matters here right now is this one. I'm going to leave these two up because these are the ones that are actually feeding the recording process for the cameras. So the guys won't thank me if I turn those down. But this one is the one that we are using for the PA, this master here. So for now, I'm going to just turn that down. I'm also going to turn down the microphone, and I'm also going to go to the gain. I'm going to turn that down. And this would be my starting point for my microphone. I would have the gain turned down, I would have the fader turned down, and maybe I need to first of all make a decision on where I'm going to put this master fader. Let's assume I don't know where to put it, so I'm going to put it at, let's say, minus 20 dB, because I'm a bit worried that if it's louder than this, somehow it will all be too loud. I'm not saying this is right or wrong, I'm just going to put it in there as a starting point. The next thing, in terms of setting up this microphone channel to be heard, I would push the fader up. Now I often use -5 as my default resting point for the fader. Can you see this is calibrated in decibels? Infinity means it's turned down to infinity, i.e. there's no signal. And I will turn up until probably around -5. Now the reason I like using -5 as my default point is it gives me from -5 to +10. That's 15 decibels, 15 dB of adjustment. If you've got somebody that's got really bad microphone technique, sometimes you will need to find 15 dB of boost on the console to make up for the fact that they don't have the microphone in the right place. So -5 is a good starting place, I would suggest to you. So we take the fader up to your favorite default position. We get the performer to perform, and in this case I'm using the microphone close to my lips, and now I can start to introduce gain until I start to hear the sound system in the PA at the volume I want to hear it. So here we are, we hear the sound system in the PA. Now there are two things now, or at least two things that are really worrying me. The first thing is that even though I'm getting the volume I want to hear, if you look on the signal indication lights for the channel, you will see that we're driving this very hard. Can you see that we're almost into the red? If you want to see a channel in more detail for the signal lights, you can press the PFL button. It stands for pre-fade listen. And then this channel's activity will be put onto the main faders of the mixing console. You can see it up here. And can you see that we are driving this channel very hard? Well, you would also be able to hear this in your headphones when you press the PFL button. Not only do we put the signal onto the main faders and we ignore all the others, but we put this channel into your headphones. You can see that I am driving this channel very, very hard indeed. And in fact, if I get excited on the microphone, you might be able to hear on the DVD an unpleasant amount of distortion. And that distortion is because we are absolutely overdriving the channel. There's a clue. If you look at the position of the gain knob, you can see that it's very much out of range. We have had to turn it up so loud before we get the energy that we're wanting to hear. And this is just not correct for
general microphone like an SM58 hitting the gain structure of a normal desk. Let's make sure we haven't got the pad down, because that would be wrong. The pad is not down, so we've got the maximum signal hitting the gain knob, but yet we're still having to turn it up so loud and it's distorting.
So something somewhere in this gain structure setup of the mixing console is incorrect. And if we look to the master fader, the clue is the reason we are having to drive the input of the console so hard is because we've got the output of the console turned down so low. This is an inappropriate gain structure setting that is making me overdrive the console. So let's reset. Let's turn down the fader and turn down the microphone, and let's make a mistake, but let's go the other way. Now I've taken the master fader well up to its absolute maximum, which is 10 dB hotter than the 0, and I've gone right up to the maximum, and let's repeat that process. So first of all, I take my fader maybe to -5. You can take it to 0, but I like to leave 15 decibels in the bag, not 10 dB. So I'm around -5. I bring the microphone to my lips, I turn up the signal until I get what I need, and now I'm listening to the output of the system. If you look with me to the actual signal lights that you can see here, you can see that we're seeing very little activity. Even though we've got a good level of sound, we're seeing very little activity on the signal light. Only the first light is lighting. And if we PFL it, you can see that we are only lighting a few of the signal lights. In this situation, we're now underdriving the console. There is not enough input signal coming into the console, which means that we will have a lot of headroom available to us in the console, but now you will really struggle. All of your monitor sends will be difficult to get loud enough because there's not enough signal on the channel to make them effective. The noise performance of the console will be very poor. It will sound hissy. You will hear bad noise performance. We call this signal to noise ratio, and that will be very poor. Right now, you won't be able to really hear this, but this speaker is hissing in my left-hand ear because it's amplifying the bad noise that we're sending to the amplifier. It's not the amplifier that's noisy, it's the bad gain structure setup on the console that has made it so. This concept of headroom is very important to sound engineers. We have an average level signal, but any signal that's coming from live performance or live program will have peaks in it, and so we need to set an average, but we need to allow headroom to allow the peaks to come without distorting any part of the signal flow. So headroom is the amount of perceived clean increase in volume you are allowed before we start to get signal distortion. But remember, if you set up for too much headroom, you will end up with very poor signal to noise performance. So this is a balancing act. If you have no headroom, you will have great signal to noise ratio, but if you have too much headroom, you will have bad signal to noise ratio, and so we are looking for a balance between these two things. So we've shown you on the mixing console these two examples, and looking in detail again, first of all, we made our output of our mixing console inappropriately low, which meant that we had to overdrive our inputs to get reasonable volume, which then led to distortion. We then looked at going the other way, where unfortunately we set the output levels way too high on the master, which meant that when we sent gain into the channel, we achieved our signal level audibly to our ears at way too lower electronic signal coming into the channel. And this is bad for noise performance. In fact, where we want to be is somewhere in the middle. And let me try -10. We tried -20, which we found was ridiculously too low. Let's go up by 10 dB. Now, 10 dB in any acoustics or electronic mixing is a significant change. If you increase something by 10 decibels, you have made a significant change. You could think about that as you've made it twice as big. So now we've set this 10 dB up. Let's see what kind of results we get when we go through our calibration process. Again, I need the signal. I bring it up until it's loud enough. And I can hear that I'm getting the signal I want to hear. It would appear that I've got a reasonable level of signal coming in. If I PFL it, I can see it in more detail being shown here. But be very careful. If this performer were to get excited, I am excited. Can you see that we are running out of headroom? It's not as distorted as it was before, but for me, this is too close to the wire. In fact, I would still suggest to you that minus 10 dB is too low for the master on this console. Let me change it. So again, drop the signal, drop the gain, increase to 0 decibels. Let's try this. -5 on the main fader. Turn up until we hear the level that we want to hear. PFL the channel, yes we are. We can see the signal now is nicely in the middle of the range when we hear it. This will allow enough headroom for me to get excited on the microphone without actually running out of electrical capability within the channel. Let me do that for you so you can hear it. I am excited. Can you see that here we have no clipping? We did not hit any limits here. I am excited. There are no peaks here. There are no peaks to show in detail. This will remain clean. We will have good signal to noise ratio and good headroom. So now this calibration process is complete. We have tried inappropriate gain structure for the master output. We've been too low, we've been too high, and we have found our happy resting place, in this case at 0 dB. And now I'd like you to consider that the master fader now is locked down. You don't really want to be changing the master fader throughout the actual performance or the service. If something is too loud, I would like you to consider making it quieter on the channel faders or the group faders rather than changing the master. I would like you to consider that the master fader on a mixing console is a calibration setting. Now that we've gone through this calibration procedure, there is no real need to be looking at meters when you start to sound check your individual instruments. It should be as simple as this. And remember, I'm using the mixing console upside down. Let me take you down and we'll go through this process one final time. We have got the gain, it's been set. It's going to stay at 0 dB in our case. We are going to push our channel fader up, maybe to -5. And then we are going to make sure that the musician is performing. We need a vocalist to be delivering energy into a microphone with good microphone proximity. And then looking at the mixing desk, we are going to take hold of the gain knob and we're going to turn up the gain until we hear what we want to hear. You will notice that I am not looking at a meter. I am using my ears and I'm listening until it's loud enough for me, and then I stop. I am not really interested in the position of the actual LEDs because I've already been through a calibration procedure. You will notice now, if I get excited, I am excited. You will notice that I am within all of the limitations of the console because of the pre-calibration that we've already carried out. Now your mixing should be about rotating gain structure and listening. It should not be about viewing a meter. We mix with our ears, not with our eyes. So this idea that we mix with our ears, not with our eyes, when we've done a mix on a console, when we've been using that approach, and I will remind you that what we're doing is, if you come with me into detail, we are setting our fader to in our mind, a default calibrated position. And then I'll remind you what we're doing is we're turning up again until we get something that we want to hear. When we do this, we're mixing with our ears, and therefore, when we've finished our mix, you will find that the default position of all of the faders, and I'll come off this microphone back onto my tie clip, you'll find that the default position is at the same place, and in my opinion, a mix engineer that's using good gain structure discipline will have all of the faders in exactly the same level, all the channel faders anyway, and in my case that's a -5. Some people will prefer to use 0. I don't mind, providing you have made a decision and you implement it. Now this is something that I quickly mixed earlier, which if I unmute you'll hear it. Now, we'll get into the mixing details of that later, but what it does mean is if I accidentally lost my way and I've lost my position of all of the faders and I don't know how to return to where I was, because I've been using good gain structure discipline, I know that on all of the active channels, if I return back to a rough -5 position and unmute, I will have a reasonable mix in place. If you are the kind of person that mixes like this, then it's very hard to return this to anywhere. You have no reference. So I would really encourage you to use the procedures I've explained to set gain structure throughout the whole of your mixing desk. And we'll explore this idea when we come to mixing in another section.
Before we start to look at the individual controls of the mixing desk, I think it's important to remind ourselves what the whole signal flow is. So, we're starting at the source. We're taking that source, which could be a musician. We're going to mic them or perhaps DI them. We're taking that through our multi-core into the mixing desk. From the mixing desk then, it's going out into our processor units and our amplifiers, out to our speakers and ultimately into our ears. Now, the different aspects of the mixing desk that I'm going to be talking today are specific to this Allen & Heath GL2400 console. However, the tools that I'm going to teach you are going to be completely transferable onto any size of console, big or small, whether it's digital or analog. Okay, so let's look at the geography of the whole mixing desk as we dive in detail. Here, we have our various inputs on the mixing desk. There are 16 inputs on this desk here, with our master section in the middle, and then another 8 channels on the side. This is, of course, therefore, a 24-channel desk. In our master section in the middle, I have my main left-right faders. These are the yellow ones. And these are my subgroup faders, the red ones here. Up here, I have my matrices. We'll come and talk about those much later on in this section. In order for me to explain what's going on, I'm actually going to plug a microphone in and walk you through the different stages. So get your headphones out. The headphone icon has appeared. So start listening as we go in detail and start to play with some of these controls. So the first thing I'm going to do is plug in my microphone, and I'm going to use channel 14 today. It's important to remember that although we're looking at a vast array of controls, actually, once we know what each control for channel 14 does, it's exactly the same for all the other channels on the desk. So don't be daunted. We're going to look at this. Once you know that, you know 90% of the desk. So the signal from my microphone travels through the desk chronologically as we work down the desk. So we have our preamp section at the top. This includes our gain, our phantom power, and high-pass filters. We then have our EQ section. This is where we have the ability to manipulate the tonality of the mics as they come into the desk. Further down, we have our auxiliary section. These are additional outputs separate to the main master outputs, the main left-right. These are auxiliary outputs. We'll talk about those in a little bit. Finally, we have our fader section. This also includes the routing. We can route the audio through different places in the console. Most commonly, we'd be routing straight to the main left-right faders, the master faders, but equally, we could be routing into a subgroup. Okay, so let's get this mic live, shall we? Now, I'm working on channel 14, so the first thing I've got to do is pull my fader up and unmute it. I'm going to take my fader to -5, okay? That's a really good sound check principle, fader to -5 before you bring the gain in. Now, I know that this is a dynamic mic. Of course, if it was a condenser microphone or perhaps a DI box that requires power, in that case, I will be pushing in the phantom power button to power up that mic or DI. I don't need it because this is dynamic, so I'm going to leave my phantom power button out. I'm going to track straight down to my gain control then, and what I'm going to do, I'm going to mute the microphone that I've been presenting with and switch only to this mic, so it's going to go silent for a sec as I spin the gain in and the volume will get louder. This mic, I'm going to keep talking into this mic. There will become a point now when you can hear what's going on in this microphone. So you are only listening to this mic. Just to prove that, I'm going to move the mic away from my mouth, and you will hear nothing. Okay, so you're happy that we are just listening to this microphone here. So I've set my gain control according to what is a good level in the PA system. I've not set it according to how many LEDs I've got flashing. In fact, I've set it to what I feel sounds right because I am a sound engineer, not a visual engineer. That's really important. Set it to how it sounds right. Once I know that it sounds right in the house and I've got an appropriate level for what I'm doing, I can then press the PFL button. PFL stands for Pre-Fade Listen. This is going to do two things. Firstly, it's going to put the mic into the headphones. The headphone socket is up here on this desk. So when I'm referencing on the desk trying to find the channel, I can hear it through the cans. Also, it's going to put my mic into the meters up here so that we can see that there's level coming in. This is a great reference because although I know it sounds okay, I should sanity check to make sure that I'm not getting red lights flashing away on the desk. If I have got red lights, then the desk is distorting itself and clipping and it's going to sound really bad. Okay. It might be that the signal coming into the desk is really too strong. It's far too hot. In which case, what I can do is use the line button or a pad button or an attenuation button. This pad, this line button, will reduce the signal by 20 decibels. So I hope you can appreciate at the moment you're listening to me at a comfortable listening level. I'm going to hit the line button and we're going to see what happens. I'm going to keep talking as I do. Now, you'll notice that the volume has dropped significantly. In fact, I'm going to adjust my gain control again to bring the level back up to where it was to compensate. Can you see, by putting the line pad in, I've attenuated the signal so much that I've had to boost the gain to compensate. Now, the problem at the moment is that my gain control is right at the farther reaches of its travel. I don't want that to be the case. I want to make sure that I'm operating right in the middle of my graph paper, not right down at the bottom or right at the top. So I need to regain structure what I'm doing here. So I'm going to take my microphone gain right back down to 0. So again, it's going to go quiet. As I take the gain down to 0, sorry, not 0, I should say minimum. Once it's back to minimum, I'm then going to take the line pad completely out. Now as I spin the gain back in again, we've got the gain control in an appropriate position. We've got travel above and below where I need to go so we can ride the gain if I need to. We're right in the middle of our graph paper now. Okay, the next section we've got is our EQ section. As I say, this is the ability for us to change the tonal controls of the mic. The first thing that I want to point out is the HPF. This is the high pass filter. If you're really looking closely, you'll see that it's working at 100 Hertz. This means that the filter is going to filter out anything below 100 Hertz. It's going to let the highs past. Okay, you might also hear it referenced to as a low cut filter. Now I've pushed it in, And you should hopefully hear that some of the really low frequencies, some of the mumbly bumbly noises have disappeared from my mic. I'm going to pull it back up again just so you can see what's going on. So currently the filter is on and now it's off and there's a little bit more boom and now it's back in again. Now in a big live PA context where you've got amplification really driving these mics hard, it's much more noticeable than it is on headphone reference levels. So, for me, anything that doesn't have low frequency energy, a voice would be key here. Anything that doesn't have that low frequency energy, I'm going to put the filter in, okay? There are 4 things I don't put the filter on for. They are the kick drum, a bass guitar, a DI'd keyboard, and any playback device. By playback, I mean MP3 players, iPods, CDs, DVDs, Blu-rays. These are already mastered and they carry a lot of low frequency energy and we don't want to lose that. For everything